Hello students, today we are going to understand the application layer. The Open Systems Interconnection, that is OSI model, is a reference tool for understanding data communications between any two networked systems. It divides the communications process into 7 layers. Each layer both performs specific functions to support the layers above it and offer services to the layers below it. So, what is an application layer and how it is important for the network communication? Layer 7, the application layer, provides an interface for the end user operating a device connected to a network. This layer is what the user sees in terms of loading an application such as web browser or email client. That is, this application layer is the data the user views while using these applications. Examples of application layer functionality include support for file transfers, ability to print on a network, electronic mail, that is email, electronic messaging, browsing the World Wide Web. When accessing information on a device, the data may not be physically stored on that device. If that is the case, a request must be made to the device where the data resides. The architecture of application layer has different types, mainly client server architecture, peer-to-peer architecture, hybrid of client server. The client server architecture. The client server model operates mainly on the concept of an always on server to whom a client may connect it to. The server normally has a static IP address and an associated DNS, that is domain name server record, to allow hosts to look it up. Clients may come and go and are never directly connected to each other. Applications that communicate between hosts using the client server model must send information through the server, which may be problem if the server happens to go offline. The biggest advantage of the client server model is the centralization of resources, that is usernames and passwords, files and databases. An example of the client server architecture is the web server and browser. Servers are repositories of information processes on the server control the delivery of information to the client. The information is usually shared with multiple clients. Web server, FTP server, database server. The server runs a service or process, sometimes called a server daemon, like other services, typically run in the background. Servers are not under an end user's direct control. Servers are described as listening for a request from a client. Servers are programmed to respond whenever the server receives a request for the service provided by the daemon. When a daemon hears a request from a client, it exchanges appropriate messages with the client, sends the requested data in the proper format. Peer-to-peer architecture. Two or more computers are connected via a network and can share resources such as printer and files without having a dedicated server. End devices peers can function as either a server or client depending upon the required service. One big disadvantage of P2P networking is that it decentralizes the service on a multi-user network. Maintaining security and access policies on a P2P network is definitely a challenge. All policies and usernames and password must be maintained on each peer device. Hybrid of peer-to-peer and client server architecture. The hybrid architectures try to combine the advantages of both client server and peer-to-peer architecture. The objective is to provide better scalability than the client server model. Simply, protocols provide the rules and formats that governs how data is treated. Application layer protocols are used by both the source and destination devices during a communication session. The application layer protocols implemented on the source and destination host must match. The application layer uses protocols that are implemented within applications and services. Applications provide people a way to create messages. Application layer services establish an interface to the network. Applications and services can use multiple protocols. It encapsulates the protocol. Be encapsulated by a protocol. Invoke other protocols. For example, using a web browser, HTTP, that is Hypertext Transmission Protocol, may invoke DNS, ARP, ICMP. It may use TCP, UDP, Ethernet, PPP, much more later. Definitely uses IP. Commonly used protocols. Telnet. Telnet is an application layer protocol used on the internet or local area networks to provide a bidirectional interactive text oriented communication facility using a virtual terminal connection. Telnet was developed in 1969 beginning with RFC 15, extended in RFC 854 and standardized as Internet Engineering Task Force, that is IETF Internet Standard 8, one of the first Internet standards. Historically, Telnet provided access to a command line interface, usually of an operating system on a remote host. However, because of serious security concerns when using Telnet over an open network such as the internet, its use for this purpose has waned significantly in favor of SSH. The term Telnet is also used to refer to the software that implies the client part of the protocol. Telnet applications are available for virtually all computer platforms. Telnet by default does not encrypt any data sent over the connection, including passwords, and so it is often feasible to eavesdrop on the communications and use the password later for malicious purposes. File Transfer Protocol, that is FTP. The File Transfer Protocol is a standard network protocol used to transfer computer files on a computer network. FTP is built on a client-server model architecture and uses separate control and data connections between the client and the server. FTP users may authenticate themselves with a clear text sign-in protocol, normally in the form of a username and password, but can connect anonymously if the server is configured to allow it. For secure transmission that protects the username and password and encrypts the content, FTP is often secured with SSL, TLS, that is FTPS, SSH file transfer protocol, that is SFTP, is sometimes also used instead, but is technologically different. The first FTP client applications were command line programs developed before operating systems had graphical user interfaces and are still shipped with most Windows, Unix and Linux operating systems. Many FTP clients and automation utilities have since been developed for desktops, servers, mobile devices and hardware, and FTP has been incorporated into productivity applications such as web page editors. HTTP, that is Hypertext Transfer Protocol. HTTP functions as a request response protocol in the client server computing model. A web browser, for example, may be the client and an application running on a computer hosting a website may be the server. The client submits an HTTP request message to the server. The server, which provides resources such as HTML files and other content or performs other functions on behalf of the client, returns a response message to the client. The response contains completion status information about the request and may also contain requested content in its message body. HTTP is an application layer protocol designed within the framework of the Internet Protocol Suite. Its definition presumes an underlying and reliable transport layer protocol. Transmission Control Protocol, that is TCP, is commonly used. However, HTTP can use unreliable protocols such as User Datagram Protocol, that is UDP. For example, in Simple Service Discovery Protocol, that is SSDP. HTTP resources are identified and located on the network by Uniform Resource Locators, that is URLs. Using the Uniform Resource Identifier, that is URI, schemes HTTP and HTTPS. URIs and hyperlinks in hypertext markup language documents form interlinked hypertext documents. SMTP, that is Simple Mail Transfer Protocol. Simple Mail Transfer Protocol is an internet standard for electronic mail, that is email transmission, first defined by RFC 821 in 1982. It was last updated in 2008 with extended SMTP additions by RFC 5321, which is the protocol in widespread use today. Although electronic mail servers and other mail transfer agents use SMTP to send and receive mail messages, user level client mail application typically use SMTP only for sending messages to a mail server for relaying. For receiving messages, client applications usually use either POP3 or IMAP. Even though proprietary systems such as Microsoft Exchange and IBM Notes and webmail systems such as Outlook.com, Gmail and Yahoo Mail use their own non-standard protocols to access mailbox accounts on their own mail servers. All use SMTP when sending or receiving email from outside their own systems. DNS, that is Domain Name Server. The domain name system is a hierarchical distributed naming system for computers, services or any resource connected to the internet or a private network. It associates various information with domain names assigned to each of the participating entities. Most prominently, it translates more readily memorized domain names to the numerical IP addresses needed for the purpose of locating and identifying computer services and devices with the underlying network protocols. By providing a worldwide distributed directory service, the domain name system is an essential component of the functionality of the Internet. The domain name systems distributes the responsibility of assigning domain names and mapping those names to Internet resources by designating authoritative name servers for each domain. Network administrators may delegate authority over subdomain of their allocated namespace to other name servers. This mechanism provides distributed and fault-tolerant services and was designed to avoid a single large central database. An important and universal function of DNS is its central role in distributed Internet services such as cloud services and content delivery networks when a user accesses a distributed Internet services using a URL. The domain name of the URL is translated to the IP address of a server that is proximal to the user. The key functionality of DNS exploited here is that different users can simultaneously receive different translation for the same domain name, a key point of divergence from a traditional phone book views of DNS. This process of using DNS to assign proximal servers to user is key to providing faster response time on the Internet and is widely used by most major Internet services today. Bootstrap protocol. The Bootstrap protocol, that is BOOTP, is a computer networking protocol used in Internet protocol networks to automatically assign an IP address to network devices from a configuration server. The BOOTP was originally defined in RFC 951. When a computer that is connected to a network is powered up and boots its operating system, the system software broadcasts bootp messages onto the network to request an IP address assignment. A bootp configuration server assigns an IP address based on the request from a pool of addresses configured by an administrator. BootP is implemented using the User Datagram Protocol, that is UDP, as transport protocol. Port number 67 is used by the server to receive client requests, and port number 68 is used by the client to receive server's responses. BootP operates only on IPv4 networks. Historically, BootP has also been used for Unix-like diskless workstations to obtain the network location of their boot image in addition to the IP address assignment. Enterprises used it to roll out a pre-configured client, that is, for example, Windows installation to newly installed PC. Originally requiring the use of boot floppy disk to establish the initial network connection, manufacturers of network cards later embedded the protocol in the BIOS of the interface cards as well as system boards with onboard network adapters, thus allowing direct network booting. SNMP, that is Simple Network Management Protocol. Simple Network Management Protocol is an internet standard protocol for collecting and organizing information about managed devices on IP networks and for modifying that information to change device behavior. Devices that typically support SNMP include routers, switches, servers, workstations, printers, modem racks, and more. SNMP widely used in network management system to monitor network attached devices for conditions that warrant administrative attention. SNMP exposes management data in the form of variables on the managed systems, which describes the system configuration. These variables can then be queried and sometimes set by managing applications. In typical uses of SNMP, one or more administrative computers called managers have the task of monitoring or managing a group of hosts or devices on a computer network each managed system executes at all times. A software component called an agent which reports information via SNMP to the manager. An SNMP managed network consists of three key components: 1. Managed device, 2. Agent, software which runs on managed device, and 3. Network management station, that is NMS, software which runs on the manager. A managed device is a network node that implements the SNMP interface that allows unidirectional, that is read only, or bidirectional, that is read and write access to node specific information. Managed devices exchange node specific information with the NMSS. Sometimes called network elements, the managed devices can be any type of device including but not limited to routers, access servers, switches, cable bridge, cable modems, bridges, hub, IP, telephone IP video cameras, computer hosts, and printers. An agent is a network management software module that resides on a managed device. An agent has local knowledge of management information and translate that information to or from a specific form, that is SNMP. A network management station, that is NMS, executes applications that monitor and control managed devices. NMS provides the bulk of the processing and memory resources required for network management. One or more NMSs may exist on any managed network. Common Management Information Protocol. The Common Management Information Protocol, or CMIP, is the OSI specified network management protocol defined in ITU-T recommendation X711 ISO/IEC International Standard 9596-1. It provides an implementation for the services defined by the Common Management Information Services specified in ITU-T recommendation X.710 ISO/IEC International Standards 9595, allowing communication between network management applications and management agents. CMIS and CMIP is the network management protocol specified by ISO/OSI network management model and is further defined by the ITU-T in the X.700 series of recommendations. CMIP also provides good security support, authorization, access control and security logs and flexible reporting of unusual network conditions. The application layer is responsible for directly accessing the underlying processes that manage and deliver communication to the human network. This layer serves as the source and destination of communications across data networks. The application layer applications, protocols and services enable users to interact with the data network in a way that is meaningful and effective. In this lecture, we have learned about application layer and its importance in network communication, its functionality, protocol and various types of server architecture. Thank you.